Okay, sounds good. Let's get started. So what is this about? I think the topic or the title of this changed a couple times, so it might be a little all over the place. But thinking back on like my journey, coming back, spending a lot of time out in California with Mike in 1678, and then coming back and joining 6328 the last few years, kind of wanted to take everything I learned both from Mike and his team and all of my experience growing up. Just a quick intro. My name's Dave. I've been around FRC since about 1999, so not quite as long as Joe, but thanks to my dad starting the team back in 99, he kind of dragged me to all the meetings, whether I wanted to or not, so thanks to my dad for that. He started Team 228. Growing up, I did FLL, FTC, and VEX, FRC all throughout my high school career. Mentor alum of Team 2168, the Aluminum Falcons, and 1678 Citrus Circuits out in California. I'm the current president of the board and one of the technical mentors for 6328. Spent a lot of time volunteering for NE first, went to WPI, so it's good to be back. Current senior mechanical engineer, Forum Labs. I love to run and hang out with my girlfriend's dog, Blue, who, good stress relief. So what's this all about? So, yeah, as you can see, I made sure to put on enough deodorant today that I wouldn't be sweating as much as Steve Ballmer, but this is all about systems. So what's really the point of a system or anything that we're doing within FRC? Really, when I was coming back to 6328, they had a really good core structure, a good group of mentors, and the team was growing. The team was growing really fast. Had found some competitive success both on and off the field. And I really started thinking of, as I moved into my role as president, taking over for Katie, who had done an amazing job building up the program since its inception, along with all the other mentors, really wanted to focus on long-term sustainability. We wanted to focus more on getting more involvement of the students. I think that, a common thing that happens with a lot of teams is you'll have a really tight-knit core group of students that are like really making the impact on whether it's doing the awards or doing the actual building the robot. So trying to develop systems so that you could actually like give more ownership and get more people involved, make the team more efficient because I wanted to have more time to spend with the dog, and try and develop a little more easy onboarding for mentors and students, and make some consistent and simple trainings for the students. So how do you get started with building systems? Step by step. I think that it's different for every single team, and these are just kind of the systems that that not just me developing, but the whole team, and systems that we've copied from a lot of other people. Special thanks to like all of my mentors growing up, Mike 1678, 2168, 228, AFT, which was the startup I worked at out in California, Forum Labs, my bosses, their bosses, my parents, and friends and family. I think all of this is just kind of a culmination of those experiences. I just tried to put them together to see like, oh, this is really impactful stuff. So let's start off with some mentor systems. So this can be very basic or it can get very in-depth, and it really depends on every team. So this will be a little bit of an insight into how 6328 does things, and just one example, people find a lot of success in doing it in a lot of different structures, but within that, there's always got to be that core system that you put together that helps drive the whole group. It's not just one person that's pushing the success. It's always a lot of people over the course of very many years putting a lot of stuff and a lot of effort into stuff. So, mentors are really the key to every team, and it doesn't really matter the level of involvement. Like having a good leadership structure is really critical to building a robust program that's going to be extremely sustainable. The mentor systems also, I find, if you spend a lot of time building these out and put a lot of forward thinking, it lets the students really do the work, and then the mentors can spend their time, guiding the boat, doing the trainings, helping develop all of this stuff in the off seasons. And it really like goes back to what Coach was saying, like giving more experiences to the kids. Like if you build out these structures, it'll really help you give those students more experiences. It's important, so just getting into a little bit of the logistical bit, when you're building mentor systems, it's like independent of every team. So it's kind of important to do this based on your team's needs. If you leave here and you copy what we do, it will be a different experience than we've found. And the last bit of this is, Coach talked about trust in his presentation, and I think that this is really like the epitome of all of that. When you build these systems that allow you to trust in your fellow mentors and the other students to do their best work, it really helps bolster all of that and really brings the team up from the community. So this is, I hope this was okay. I didn't even ask if I could show this, but this is 6328's core structure. So you can see there's a couple different elements of it. We're an independent 501c3 nonprofit. So we have a board of directors. Then we have FRC core mentors. And those core mentors are kind of mostly in charge of all of the different sub-teams that we have. And then we have a couple different offshoots. So we have our Girl Up Club, and then our 2 branches of FLL. So this is kind of the whole hierarchy of the high-level structure, but then it breaks down a little bit further within that. So just talk a little bit about the day-to-day. So the nonprofit board of directors, we really don't do too much. We meet once a year, and we just talk about ensuring long-term sustainability, make sure we have an emergency fund, make sure that we're kind of all on level plane with what we want the next 1 year, 3 years, 5 years, 10 years to look like. And then a lot of those get passed down to FRC core. So a lot of us that are on the board are also part of the daily bits of it. With FRC core, this is, it's something that I picked up from Mike. They have their core, and for us, we tried to expand it a little bit so it includes sub-team leads. So within all of this structure, you can see there's a lot of different elements that's broken off. So I primarily focus on project management. Then, we're very lucky to have a lot of different mentors that can kind of specialize in stuff, but you'll have some cross work between a lot of stuff. You'll see Katie and Michelle's name on quite a bit of stuff. So what does FRC Core do? So those mentors are really like the backbone that are driving the daily operations and the tasks. Those are the ones that are really helping facilitate the trainings in the off season or even during the season, and then they will run individual budgets for sub teams. So part of that trust and part of also giving people the ability to have a lot of autonomy is building in a structure and a system so that they can actually take their own decisions and make their own decisions and move quickly. We all know that time is one of the most valuable resources, not only in life but in FRC. And this really lets a lot of people have kind of their own individual overseeing of what the students are working on, making sure that overall program, that overall sub-team is moving in the right direction. And then we have our FRC mentors that fall outside of the FRC core, but there's a few of those, and we really have been putting a lot of emphasis to utilize those mentors to ensure the student experience is as good as it can possibly be, right? So these mentors are also kind of subject matter experts, so we have some industry professionals that specialize in FEA CAD. So they'll do a lot of analysis on our specific designs. They'll do video editing, they'll help with grant writing. There's any specific thing that we can give them ownership over a small bit of it and then help teach the students. That's really impactful for the team. And then this really helps engage some of the students that are on the fringe is maybe the wrong term, but that are not totally ingrained or are just getting started. And these mentors can really be a really good resource because they can spend a lot more one-on-one time with certain students that need a little bit more help, that need a little bit more understanding with it. And then they assist with some of the daily tasks. So within the structure of mentor orgs, which I'm sure a lot of you have these mentor sub-team leads and stuff, within this, I think it's important to build systems within this so that you can actually try and foster better communication, which is one of the biggest impacts that a team can have across the whole board of moving everybody in a single direction and making a really large impact for a large number of students. So once you've kind of got the structure in place, it's really important to take a look at how you can build specific systems so that you can support communication. So some examples of this is we'll do mostly regular core meetings where we'll take specific meeting minutes. In those meeting minutes, everybody will get assigned certain tasks, and then as you have your next meeting, you're pulling in your to-dos from the last meeting, double checking everything. Does that still track with the same thing? So we've built out a system within our meeting minutes that lets us make sure we're continuing to move in the direction, and it's very easy to just talk about it in a meeting, and then it ends up on a to-do list, and who's really looking at it, right? So this just helps keep everybody accountable. One-on-ones, I think that this is something that we're starting to do more, and we've started to do them of those students or those mentors that are outside of core and want to get more involved. We're finding as students or as mentors get more and more experience, we're really trying to pull them deeper into the program and get all of us moving in the right direction. So doing a one-on-one with them and just sitting down and being like, hey, what do you want to get out of this? What was your experience last year? What did you learn? That was really insightful. Max and I just went and got dinner with one of the mentors, and it was a great dinner to just get his perspective from outside core, and it kind of made me rethink a couple things that we did and better understand all of that. And really what this happened, when all of this stuff is happening, is got to be independent to you. I think the big portion of all of this is, as you're building out these systems of better communication, is you need to be honest with yourselves of we don't meet all year. We start meeting in the fall, we come back and we leave after April and we don't come back until the fall. So is there anything we can do in the off season? Just touch base. Once we get back, let's make sure we have a core meeting and we get off on a running start. And there's a lot of specific things that it's kind of endless within the mentor organization that you can impact on. So the next bit is build team structure. So build season structure. So this is kind of going to be sporadic because these are just the big impact things that I've found. For people that have known me for a long time, it might be interesting to them that I'm giving a presentation on systems, given how much I like just brute forcing and doing things without planning much. I see Mike giggling over there from our time at AFT. But putting in structures and actually just thinking a little bit about this can go a really long way. In developing some concrete structures for build season, gets everybody on the same page. It helps everybody kind of move in a similar direction, and it kind of just helps you from flailing in space. So what does build season structure look like? I think there are a lot of different elements of what it can look like. Again, it's up to your team to how deep you want to go into it. I think it would be mildly surprising to a lot of people how kind of high level our planning is. So the second bullet is just an example of our planning for the build season, right? So these are the high level goals that we want to hit. So week 1, we're really focused on prototypes. Week 2 and 3, we build something that's called the dev bot. It's just a bunch of high fidelity prototypes put together on a functioning thing. 4 and 5, primarily building comp, and then week 6 is practice. So, I think that a lot of teams fall into the trap of being a little too granular in their planning. And in the reality of the situation, and we've all been through build seasons, right? So we know that it's going to hit the fan eventually. Sometimes things just you got to scrap old design, you got to move back, you got to be flexible with the understanding. So not getting too in the weeds and spending too much time doing granular building out these Gantt charts and to-do lists and stuff is important. So yeah, just a quick graphic of what it looks like. This is kind of what we'll be mildly presenting to the kids this year to be this is what to expect. Okay, so jumping into the next bit of it is design reviews. So this will be a little bit more in depth. So this is something that I really learned from Mike and Citrus, and something that I think they do particularly well is during the build season, they're kind of the North Star of building efficiency, right? I don't know, they build alpha robots, beta robots, many iterations before they even get to their first event. And how does that really ever happen? I think that some of the key bits of it is the actual cycle that they go through doing these design reviews. So there's really a system that they've developed that we've kind of mirrored and then adapted a little bit that really helps with students and mentors to provide feedback as you're developing CAD. So this is very CAD specific in this sense. So how do we do it? So there's a couple critical tools that we use that we know not everybody has access to, but I think that the glory of developing these systems is it doesn't really need to be Slack. It doesn't need to be lists within Slack. It can kind of be whatever you have access to. Like you could really realistically do this in like Google Sheets if you wanted to. But a couple of the key tools that we use is we solely use Onshape, completely converted over. Drew's got a great presentation later today on Onshape that kind of talks about it, but I can't recommend it enough. And then Slack is a really big tool for us. So within Slack, there's this new interesting feature called Slack Lists. So who here is familiar with Trello? Yeah, so this is basically just Trello ported over, and it all lives within Slack. The nice bit is it's free if you have the like nonprofit Slack, and it gives you a lot of access to. And Trello just started charging money for everybody, so a nice free is always good. So we really established a system that kind of helped students. When we think about efficiency with this, is we're lucky where Onshape enables us to be able to do a lot of our CAD work outside the shop, right? So we can draw students' time when they're outside the shop. Maybe they're sitting in the cafeteria or they're sitting in that history class that they've already passed the test and they don't really care about. So they'll pop open their Slack and they'll look, and we'll have multiple students that are all working towards a similar goal, right? So like, how do you keep that line of communication between us developing these subsystems and the students, the like global aspect of all of the students kind of on the same agenda and kind of moving in the right direction. So this list is really just a system that enables us to provide them with feedback on stuff that they're working on. And then at any given point in time, if they have a few minutes and they want to work on the CAD, they can pull up this list, grab something on the to-do list, and continue working. So how does it work? So it's pretty simple. Our system is basically just some of the mentors, we're lucky where we have design mentors that'll just pull up open CAD, and we'll just kind of spin it and look around and just look for anything that we see might be like, you know, maybe there's some improvement we can make before we actually build the subsystem. So this example, Sam, one of our design mentors, pulled open the CAD, and this is on one of our prototype shooters for this year. He just saw that the distance between where the motor is mounted and where the nut is going to go is going to be too close, right? So, or he just wanted them to check because there's nothing in the CAD. So Sam takes a really quick screenshot of it, and then he posts in a dedicated Slack channel that's for these design reviews. And then using this neat little tool right here that's got some arrows to it, you can click on that, and this menu will pop up and you can add it to your list. So once you've selected the list that you want to add it to, you can add in more information to it. So the nice part is all of this is completely flexible, like similar to Trello. You can build out the cards, and then once it's assigned, you can assign students, you can assign them priorities of it, like certain details. You can get pretty granular depending on how. For the design review stuff, we maintain a pretty high level because we want it to just be quick information, and if there's more conversation that needs to happen, the student can add a comment and it will ping the person that created the card, and you can have a little bit of conversation about something more granular. So if they're like, oh, am I using an iLock on this, or am I just gonna like, you know, thread the, what do you think makes the most sense? You can have a quick conversation in something that's very targeted and very specific. Here's just another example. It can be as simple as I just say, like, you just need to add a little bit more material here. You know, this bolt is a little bit close to the edge and it has like a high likelihood that it could have a collision. Let's add a little bit more material there. Like, don't need to say much more than that. It takes 30 seconds to take a screenshot, create the Slack post, and send it to the card. And then this is kind of an example of what a board might look like. So it's this whole list over here is just all of the to-dos, and then as they're actively working on it, the students are encouraged to move it into the doing aisle, and that just also helps the mentors know. So like, say if something is taking a little bit of long time, we'll see that it's been sitting in the doing for a while. We'll ask the student, oh, hey, do you need any help with this, or what's the hang up, or like, bro, can you just finish this? Oh my God. And then you move everything to done, and it's honestly kind of a nice log to see all the work that you've done. Citrus did it primarily in PowerPoints, where Mike would take screenshots, add some markups, and then post in the PowerPoint. And it was always really cool for me, especially when I first joined the team, to just look back on all of the different pieces of feedback that he's given the students. And it's like hundreds of slides by the time the robots actually make it to the competition. So it's all really good stuff. So, okay, so that whole system is something that we utilize to really quickly do the design reviews. So now let's say we've gone through the design and the students are ready to actually like make the part. So one of the biggest ways that systems can really impact your team is between sub-team communications. So we struggled a lot with internal ordering of parts. So when we had a part that was ready to go to manufacturing, it would basically get like drawn on a napkin, or like somebody would send a Slack message with a part number and a quantity and maybe the material, but probably not the material. And then it was a lot of going back and forth. So this system is also utilizing the Slack lists, where we really want to be able to facilitate getting all of the information from the designer, the design intent, all of the specific information that the manufacturing student or the student that's in charge of doing the CAM for the OMIO, or the student that's going to print it on the 3D printer. We're really trying to transfer that level of information over so that the students can go on and just have their backlog of tasks, walk into the shop, and it's very little input from the mentors to say like, here's your list of stuff to do, or this doesn't make sense. A lot of the mentor touches of this are baked into built-in mentor review processes. So this process is something that we're building out in our manufacturing lead. Sean T did a really, really nice job with it. So building out cards is as easy as, instead of actually making a Slack message, you can go into the little list and create add card, and then it'll pop up with this level of information that's in the middle here. So this is a blank card. So you can see this is when a student creates a new card, it'll have a bunch of different information. So as we CAD, we really want to make sure we're doing versions on everything so the students are actually making the right parts. The robot type, so is it for a practice robot? Is it for spare parts? Is it for off-season robot? Is it for a comp robot? The machine type, the design intent is for it to be made on, because sometimes there'll be a little lack of communication where they're like, oh, this flat plate, do I print it? So some information along those lines, and then finish, quantity you need, and then move it to the next level over. So this is it was hard to get a screenshot of the whole pipeline all the way over, but moving from left to right, when you make a card, it ends up in this needs drawing file. So this needs drawing file is then, there's a subset of students that are trained to do drawings, right? That's they're gonna be their specialty for the year. They're typically younger kids, they're just learning about manufacturing, they're just learning about design. Great opportunity to get them to start looking at parts that are actually gonna be on our robot, understand design intent, and understand how it gets manufactured. And those students will just make a basic design. There's different requirements for a flat sheet metal part, or a part that's turned on the lathe. And then once they're done filling out that drawing, they'll actually add the PDF of the drawing into the comment right here. So once you make the card, you can add a comment. So we require all the students, when they make the cards, to take a screenshot of the part, add it there, and then once they make the drawing, they add the drawing there as well. And then you just move it down the line, right? So it'll go from one student who will solely focus on doing the drawing for it, and then they'll move it. So say if it's a router part, they'll move it into the needs CAM portion of it, and then the student that is in charge of doing CAM for the day won't have to have a conversation between those two at all. They're just looking at the backlog, and they're trying to do their best to pattern and just work through the priority list. So the student that is going to do this on printing, they're just going to grab this, they're going to grab as many parts as they see with this material, they're going to nest them all together in a single print, and then they're going to hit go, and their job for the day is is sorted. And then they work on to the next card. So once it makes it through needs CAM, if it's a specific part that's getting manufactured in our shop, we want to do some type of mild audit. And for us right now, this is primarily having the mentors check over the parts. So once the drawing is done, the CAM is done, then they'll drop it into the mentor check list, and this will be one of the mentors on the design team will just take a peek at it, and they'll say like, oh, like you forgot to add this dimension to the drawing, like the intent isn't there, like before we actually release it, let's bring it back to drawing, add a little note, update it, and then once we've decided that we've made it through the whole process, and this mentor check will mostly be done with the students and mentors together. Then you move it on to the ready for whatever manufacturing equipment is going to be. So if it's just a manual one, it skips the needs cam. It just goes from needs drawing, mentor check, and then we'll sit in the ready to lathe. And then if it has some finish, it will actually go from the manufacturing shop and then set up a rack. And since we do all of our powder coating in-house, we'll actually lay everything out in specific batches and say all of these parts are getting the blue powder coat. And then you'll batch everything together. So the student that's in charge of doing the powder coat for the night will walk in and just see this pile of parts and know these need to be blue by the time I leave today, or Dave will be mad. So all of this system and a lot of this is just enabling really succinct forms of communication between all of the students without having to get too granular of the actual person-to-person communication. Moving quickly and efficiently in this system is how can you build a system that allows all the students to communicate without having to actually be face-to-face in that moment. And with a lot of this stuff, it's also thinking long-term, right? So some of these parts will get pulled back. So say if we're making the comp version of it, we'll go through and we'll make all of those parts, it gets assembled, and then say we're happy with it, it's right before we need to go to competition, we need to make a bunch of spares of it. You just pull the card from done back into the ready for manufacturing, and then the students that are trained up on all of those machines can just start making all of the parts that you need for the spares. So it just is a better process of actually thinking long term, being able to push all of this stuff through in a nice succinct way. And I'm really excited to implement and really run with all of this stuff this year, because I think it's going to enable us to train individual students to do very specific things and say this is your focus for the year, let's get really good at this is your foundational bit, spend a lot of time doing this, become a subject matter expert, and then when it's for the off season, it's time to train in the next generation of students to do what you're doing, and then getting as many people involved in the process as possible. Something that I think we're guilty of in the past was, you have this core group of students that are really good and they really shine, and it always tends to be the mentors will focus a lot of attention on those students unless you're really thinking and really being active to I need to make sure that we're giving attention to all of the rest of the students. So building systems like this really kind of reminds you that you need to pay attention to a lot of different students that are going through this process and kind of helping, because if you have one student who owns parts that go through the lathe, right? If they're getting a backlog, then it kind of brings to the attention oh, we gotta go, what's the holdup? Do we need more training? Do you need more help? All of your drawings that you're getting are crap. How can we make the process better? So this whole process is really, there are some small weird bits to it. So for us, we outsource a bunch of stuff. I'll make stuff at Form Labs, or we'll have a sheet metal vendor. Those just kind of get put in a separate group, and then need to develop a more robust ordering process with them. So that's kind of coming in the future. 3D printed parts are kind of unique where they don't get any drawings, or I make them in Form Labs, so they just drop STLs. And then I talked about the ordering spares. And then for future editions, the hope is that we can eventually get to the point where this is a fully self-sufficient system where there's, aside from the initial design reviews, there's very little input from mentors on getting it to the step of being ready to be assembled. So as we have these students that are really becoming subject matter experts in all of these things, you can kind of promote them within the role to be you can now approve all of the stuff to go to get made on the lathe. We can really you can enable them and give them the foundational tools so they can actually make a bigger impact, be more, have more of a a leadership role and oversee a lot of other students doing all of the different bits of it. So this will be our first season that we're going to like fully implement this and do our trainings with it. So we've been doing kind of bits and pieces of this over the last year or so, and it's showing a lot of promise. But you know, inevitably with every system, there's something that breaks down, or like in when everything gets kind of hectic, it's very hard to really like focus in and make sure you push everything over the line. So as we're going to actively set up dates to do audits on this, kind of after we do every build, see what we need to adjust, where we need to pull more students in. And another big part with this, and I think with every system, is building an SOP. Does anybody know what an SOP is? I think a lot of the like engineers and everybody else probably uses them in work. So standard operating procedure. We've been pushing the students, like as we're building these systems, right? We're building a document that's going to live with this system, that the student who is our lead manufacturing student can pass down to the next student and be like, add comments to it, make adjustments, and this really helps with your knowledge transfer. So a big thing with systems is, you know, I see a lot of teams, and I've been on teams that struggle with the tribal knowledge, right? You have an excellent software mentor who graduates and goes to WPI, and then like you sit down with the programming team, and you're like, wow, that was a big loss. Like, what do we do? And so spending some time building out a lot of like documentation, and not to pick on Jonah, like Jonah's superb documentation. But with across every sub-team and across every student, like the hope is that they kind of leave impacting these SOPs in a little bit to help transfer the knowledge to the next group, the next student team leads, the next group that's going to actually be utilizing all of them. And the other big part of this is you actually need to like use the SOPs. So we make a lot of them at work, and then they sit in a folder, and then I don't think anybody ever looks at them again. So actually getting the students to like open them up. This year we're going to like print out these SOPs and make a little binder that lives with the student sub-team lead, and then when the sub-team lead is done with their sub-team and the next one is elected, they pass the binder to the next person, and it's kind of just like a little tradition thing, but it also kind of gets them thinking like, oh, this is cool documentation to use. Okay, completely separate from this, competition roles. So everybody here has been to a competition, right? Yeah, that should be a given at this point. So this is mildly random, but I think extremely important, the fact that there are a lot of teams that show up to events where they're just like, they've spent the entire season building the robot, and then they have no plan for who's going to check the batteries or who's going to communicate with your partners in the next match. It's extremely worth the effort to actually spend some time building out a system, assigning a bunch of roles for students, assigning roles for mentors, and kind of pushing through. So, you know, spending some time writing out all of these list of roles, I think that before you assign anybody anything, even if it seems abundantly apparent, you should have that like kind of group come together and write out the list of the roles. You know, if you've gone to events, you kind of have experience with all of it, so you can say like, you know, we need specific people that I like to use the example of like the lunch stuff, or like who helps bring the lunch from the car, just because I don't know if Cam's gonna like me telling the story, but in 2022 he missed us winning division finals because he got pulled in to help bringing the sandwiches in. So just because there was like a little bit of a miscommunication there and it wasn't perfectly planned out. So the unfortunate reality is if you like fail to plan for that, it can have negative impacts, but thankfully we got it the next year. So you got to celebrate at least a little bit. These are some examples, and we're actively building out this system more and more, where these are just a list of kind of the event roles that we have. So we kind of have the obvious one, right? Everybody needs a drive team, some human players, but then we have specific students that are assigned like electrical, software, hardware roles in the pits. Scouting's very big for us. The system operations portion of it takes one person sitting there and making sure the whole thing is running smoothly and passing out tablets and all of that other stuff. AAA is something that we're kind of getting going. It's a service where teams can, if they need help at an event, we'll provide resources to them, kind of inspired by Citrus Service, where this is just a program where any team at the event can come, ask for help. We'll send students and resources, parts, whatever you need over there. Even down to the parents. So we rely a lot on our parents for helping us get the lunches, helping us schedule rides, support in the stands. We love seeing a bunch of people in the stands, like cheering, like having a little bit of a system to say like, oh, hey, we're gonna cheer. We make sure whenever we're on the match, we're cheering for all 6 teams. Like there's a little bit of a system for that. And there's an endless amount of other roles that anybody could do at an event. So what else can you make a system for? I kind of challenge all of you to go back and think a little bit more about, what are some small things that you can implement in your team to kind of better the process as you go through. This is not an exhaustive list by any means, but it's just some funny things that I think that we're mostly implementing. And they may seem silly or like not super like important, but every little bit matters. And I think when you're doing this and you're working with the kids, like every system you can make is an opportunity for you to pull more students into the program. And that's really the big impact of all of this is, you want the student to kind of go through the program and have a really good experience with it, right? So if the student comes in, you can give them a defined role with a set of instructions, and they can really like take that and run with it. And you find the majority of the time, if you give the student something to do and like they're gonna run with it and they're gonna do a great job with it. So having all of this stuff that you can kind of pass out and all of these roles also gives a lot of ownership to everybody. And when you have the ownership, it really you get a lot more out of people. And that's something that is really makes a really big impact. So I maybe didn't go full Steve Ballmer, but I think that my like words of stuff that I've learned over like being involved in FRC, the like one thing that I've learned, and it's something that the big teams, even if they don't even realize it, that are like very sustainable and making like large impacts in the community year over year, they've built all of these systems and they have them in place, and maybe they don't like actively think that they're like setting a system, but that's ultimately what it is. So I challenge all of you, set some systems up. I'd love to hear some feedback if we run into each other at events. What did you learn? What didn't work? I think that what didn't work is really impactful. We kind of stumble through a lot of stuff and learn that the hard way. So yeah, I think that's about it. So awesome. Thank you, everybody. I think I have like 2 minutes. So does anybody have any questions? Cool. Okay, awesome. Thanks so much. So we'll take, I think it's lunch now. So lunch is going to be in the room right next door. That'll go until 1 p.m. So probably start making your way back into the room like 8 of 1. Sounds good. Thanks, everybody.